In this video, we're going to talk about an aspect of linear functions called constant rate of change and slope. So the vocabulary we're going to be using is rate of change, and that is a rate that describes how one quantity changes in relation to another, and linear relationship, which is a linear function is a type of linear relationship. So that's a relationship in which the rate of change between the quantities never changes. And the constant rate of change is that rate of change that always stays the same. And we'll also call that slope, which is the ratio of the vertical change to the horizontal change of a line. So again, a linear function is a linear relationship. So we're going to talk about what a linear relationship has, namely a constant rate of change or a slope. So how do you find the rate of change in a linear function or a linear relationship? Well, the first thing we need to do is find the rate at which the y values are changing. That's the dependent variable. And find the rate at which the x values are changing. That's the independent variable. And then the rate of change is the ratio between those two values. So it looks a lot like this ratio that I have at the bottom here. The rate of change is equal to the change in the y values over the change in the x values. Again, this is a ratio, and it's basically a unit rate. So if you remember doing unit rates in chapter 5, this will be very similar to that. So let's look at this table that shows a linear function about how much money somebody had for over 4 days. And we want to know what is the rate of change, or what is the constant rate of change between these quantities. So if we're looking for the rate of change, we want to look at how much the y values are changing compared to how much the x values are changing. So in this table, our independent variable is the days. These are our x values. And the amount of money is our dependent variable, which is the y values. So looking at the y values, how much are they changing? Well, as each day passes, we are seeing a decrease of $20 for every 1 day of change. So if we're looking for the constant rate of change here, the rate of change is the change in the y values. Notice that the change is constant. This is a constant rate of change. So the y values are changing negative $20 every 1 day. So we would say that our constant rate of change is negative $20 per day. And again, that's a unit rate. Negative $20 per day is the constant rate of change. So that's how we find a rate of change in a table or in a set of ordered pairs. Find out how much the y values are changing, find out how much the x values are changing, and write that as a ratio. How do we find the constant rate of change in a graph? Well, on a graph, remember we have many points on the graph that are solutions to our linear function. We're going to pick any 2 points on the line, and we're going to use the x and the y values in those 2 points. And then we're going to find the change in the y values and find the change in the x values. We would do this by subtracting their values to find out how much they change from one to the other. And then again, we'll write that ratio. The rate of change is the change in the y values over the change in the x values, that ratio between those two. So look at this graph that we have here that shows the growth of a plant over a number of weeks. And you'll see that we have 4 points on this graph that we can choose from. We can choose any 2 points on this graph to find our rate of change. So let's pick these 2 right here. This first point has an ordered pair of 4 weeks, 5 inches. And this point is 6 weeks, 6 inches. So to find my rate of change, I'm going to find the change in the y values and write that as a ratio to the change in the x values. So how much did my y values change from one to the other? Well, from 5 to 6, that's a change of 1. And from 4 to 6, that's a change of 2. So my rate of change is 1 over 2, or 1/2 inch per week is my constant rate of change, 1/2 inch per week. Well, what if somebody had picked two different points? Would I get a different answer? Well, let's take a look and see. What if I had picked this point and this point instead? Well, if I again find my change in y and my change in x, this is the point 0, 3, and this is the point 2, 4. So my change in the y values is from 3 to 4. So 4 minus 3 is 1. And my change in the x values, 2 minus 0, is 2. So you'll see I still get 1/2 inch per week. And you can do that with any combination of any 2 points on this graph. You will always come up with 1/2 inch per week, or a fraction equivalent to 1/2 inch per week. That's what's nice about a linear relationship, is that the change is always constant. That's why it's a straight line. It's always constant. It never changes. So no matter what points you use, you will always find that the rate of change is the same everywhere on the line. So what types of rates of change will we see in a graph, and what does it look like? We can have a positive rate of change, and that's typically associated with an increase, and you'll see in the graph that that is a line going upwards from left to right. So as x gets larger, so does y. Y also gets larger. Or you could have a negative rate of change, which would be associated with a decrease. So as x gets larger, y gets smaller. Or you could have zero rate of change, or no change at all. That means as x gets bigger, y never changes. It's just a flat line. So those are the types of rates of change that we might see. In graphs of linear functions, the constant rate of change is also called the slope of the line, and is indicated with the letter M. So just new vocabulary, constant rate of change is called slope. So how do we find the slope? Again, it's the change in the y values over the change in the x values. And then there's some other ways that we refer to that as well. So how do we find the change in the y values? So over in this picture, you'll see that I have two ordered pairs on the green line. And this blue dot has an x value and a y value, and we just call those x1 and y1. And the red dot has an x value and a y value. We call those x2 and y2. That just indicates that the blue dot is the first x and y values, and the red dot are the second x and y values. So how do you find the change in y? How much y has changed? Well, we subtract. So in this second box here, you'll see that slope is found by taking the second y value minus the first y value. That tells me how much the y value changed. And then again, likewise, to find the change in the x, or the x values, I take x2 minus x1. So that's just another way to write it. You'll probably see this more frequently written to find slope. Y2 minus y1 over x2 minus x1 is just a shorthand way of saying the change in y over the change in x. And an even shorter way to say that would be rise over run. You'll hear that a lot in math when finding the slope, the rise over the run. Well, what does that mean? This orange line is how much the graph changes vertically from the blue dot to the red dot. So that's the change in the y values, the change in the y. And then the run is how much we change horizontally. So if you think about it as running, you run in a horizontal line, you rise vertically. So the run is how much the x values changed from x1 to x2. So again, we can shorthand that as rise over run. So looking at this linear function, what is the slope of this line? Meaning, what is the rate of change on this line? So we can see we have 2 points that are labeled on here. We're going to use those 2 points to find our slope, or our rate of change. So slope is the change in the y, y2 minus y1, over the change in the x values, x2 minus x1. It really doesn't matter which one you call x1, y1, and x2, y2, but I typically go left to right So I'm going to call this one x1, y1, and I'm going to call this one x2 and y2. So to find my rate of change, I'm going to take y2, which is 6, minus y1, which is 3, and x2, which is 8, minus x1, which is 4, and that gives me 3/4. So the slope of this line, we would say, is 3/4, which tells me how steep the line is, or how fast or how quickly the rate of change is from left to right. You'll notice it's a positive number, which makes sense because our line is going up from left to right. And if you're thinking about the rise and the run, think about how much I moved vertically from x1, y1 to x2, y2. This was a rise of 3 and a run of 4 units. There is our change. There is our slope, 3/4, up 3/4. So this has a slope of 3/4. Looking at this line, we want to find the slope. Again, to find the slope of a line, we're going to do y2 minus y1 over x2 minus x1. And again, I'm going to call these x1, y1 from left to right, x2, y2. So when I find my slope, y2 is -2, y1 is 2, x2 is 2, and x1 is -4. -2 minus 2 is -4, and 2 minus a -4 is like 2 plus 4, so that's 6. So my slope is -4/6, which is -2/3. And I would expect my slope to be negative because this line is moving downward from left to right. So it is a negative rate of change, so it has a negative slope. And again, if you're looking for a visual of that fraction, my rise is actually not a rise, it's kind of a fall. So I'm going down 4 units, and I'm going to the right 1, 2, 3, 4, 5, 6 units. So -4/6 is the slope of my line, or the rate of change. Or I could go down 2/3, down 2/3. Same thing, they're equivalent. So a slope of -4/6 is the same thing as a slope of -2/3. It's the same rate of change. Now this line is a little bit different. What happens when we try to find the slope of this line? So again, the slope of my line, y2 minus y1 over x2 minus x1. And again, from left to right, I'll call this one x1, y1 and x2, y2. And you might wonder, well, what if I called the one on the left x2, y2 and the one on the right x1, y1? It really doesn't matter. You'll come up with the same slope. So don't worry about which ones you name which, as long as you're consistent that the ones are together and the twos are together. So y2 minus y1 will be 4 minus 4. And x2 minus x1 will be 2 minus -3, which gives me 0/5. So the slope of my line is 0/5, which is just 0. Well, that makes sense because this line is flat. There is 0 change here. This line is not changing at all from left to right. So my rate of change is 0, so my slope is 0. So that's something to keep in mind, that a horizontal line, it has a slope of 0. There is no increase or decrease at all. And lastly, let's look at this one. What if we have a vertical line? We haven't seen any of this before. And you may be wondering, well, I thought that we couldn't have a vertical line or 2 points on top of each other, and that does not make it a function. Well, let's see what happens when we try to find the slope of this line. Now, there isn't one that's on the left or one on the right, so I'm going to go x1, y1 on the bottom, and x2, y2 on the top. And to find my slope, y2 minus y1, x2, minus x1. And y2 minus y1 is 3 minus 0, which is 3. And x2 minus x1 is 1 minus 1, which is 0. We have to be careful here because that's impossible. You cannot have 0 in the denominator of a fraction, or you cannot divide by 0. So there is no slope here. This is what we call undefined. The slope here cannot be defined because we cannot have 0 in the denominator. So when we have a vertical line, that really doesn't function. So this slope is undefined. So in review, types of slopes, which are also called rates of change. You can have a positive slope from left to right, it's moving upward. You can have a negative slope, left to right, moving downward. You can have a slope of 0, that's a flat horizontal line. Or if you have a vertical line, that slope is undefined.